Hi, welcome back. In the previous video, we learned about DFS, which was a graph traversal technique. In this video, we will learn another technique of graph traversal, which is DFS. So let's see what we have got for you in this video. So first, we will go through what is DFS. Then we will see the working of DFS using a graph. Then we'll go through the pseudocode and finally the running time of the algorithm. So moving on, we have what is DFS. DFS is a graph traversal technique. It starts at a node which is considered as a root node. You can consider any node as the root node. It explores the graph as far as possible, and we will be visiting all the nodes which have a path possible from the root node. It is very important to note this, that every node should be visited only once, and it explore the branch as far as possible before backtracking. So we will see how it works using an example in the next slide. So as learned in the previous slide, it is very important to note two things. That first, the algorithm will explore each branch as far as possible before backtracking. And another is that each node will be visited only once. For this, I have maintained a visited array which will assure the property that no node is visited twice. So first I will explain using the graph how the DFS runs. Then I will explain how we will be using the array and the array list result to store the result. So first I am considering 1 as the root node. We will explore the branch which have a smaller number first. So 1 has 2 branches. We will be looking at 2 as 2 is the smaller one. Now 2 has 2 children, which is 4 and 5. As 4 is the smaller number, we will explore 4. As there is no edge from 4 to any other vertex, it will backtrack to 2. Then 2 will explore the other branch of it, which is 5. And then it will backtrack as there is no edge from 5 to another vertex. Now we will backtrack as all the elements which were connected to 2 were visited. Now we have 1. Now 1 will explore 3 as 3 was not already visited. Now 3, from 3 it will explore 6, then it will backtrack, it will explore 7, then it will backtrack, and finally it will be back to 1. As all the vertices which were connected to 1 are visited, the algorithm will end here. So using the visited array, I will be telling you that how we are going to be using the result array and the visited array to see how it works. As I'm considering 1 as the root node, we will mark 1 as true in the visited array and we'll store it in the result too. Now as we will explore 2, then we will mark it as true and add it to the result array, and then exploring it the branch as far as possible, we will explore 4, mark it as true and add it to the result array. As 4 do not have any vertex connected to it, it will backtrack, then we will be at 2, then 2 will explore its other branch which is 5, mark it as true, adding it to the result. Then we will be back to 1. Now 1 will explore its other branch in the same way as it explored its previous branch. First 3, marking as it true, adding it to the result array, then 6, then marking it as true, adding to the result, then backtracking, then finally to 7, marking as true, and then adding 7, then finally it will be back to 3, and then finally back to 1. So finally the result will be 1 2 4 5 3 6 7. So as you all have understood how the DFS works, let's look at its pseudocode. Before moving on to the pseudocode, we will be declaring two variables, the result and the visited array. All its working has been explained in the previous slide. So let's look upon how the pseudocode works. In the main loop, we will be running for all the vertices, and DFS will only be called in the condition if the vertex Vn is not visited, so that the property that no vertex is visited twice is maintained. So looking at the DFS function, first we will make the index u to true, add it to the array list and explore its neighbors, and if its neighbor is not visited, we will again call the DFS on it. So it is a recursive function. In the next slide, we will be looking at its time complexity. So the time complexity will be O of v plus e, where v is the number of vertices and e is the number of edges. As we know, in an undirected graph, each vertex is looked upon twice from each of its endpoints. Therefore, the loop in the DFL will run at most 2a times, which is 2 into the number of edges. And the main loop is running for at most O of v, which is the number of vertices. So together they will form the complexity of O of v plus 2e, which is approximately equal to v plus e. So in the next video, we will be learning about application of DFS, which is detection of cycle in an undirected as well as a directed graph. So that's it for today's video. Thank you.